Hey guys, guess what? This is my last video of the school year. It's not your last video, you still have to do one more, but it's my last video and I'm very excited. So let's go ahead and get it done. So in lesson 6.5, we're talking about two-way frequency tables. Our learning target is that we can create and interpret two-way frequency tables. These things are used to organize data that's categorized by two variables, and they look something like this. If my little text box will ever jump up here. There we go. All right, so they look something like this. If you are in one of my classes, then you see a two-way frequency table up on my board every day. It's how I keep track of how many students in each block or on each unit. So if you haven't ever noticed it before, look when you get in class and I'll show it to you and you can finally understand that. So here's our example that we're going to use in this lesson. If you surveyed a group of elementary school students about their favorite parts of the circus, then we could create a two-way frequency table that breaks that data up into boys and girls and then their favorite part of the circus. So the way you would read this is you'd say, okay, if I want to know how many boys liked elephant tamers, then I could go to my boy row and then elephant tamers and find that 8 boys like elephant tamers. If I want to know how many boys total there were, then I would go all the way to my total here. If I want to know how many kids in general liked elephant tamers, then I would go all the way to the bottom of the elephant tamer and I've got my totals there. So that's kind of how it works all together. This is kind of a sad example since the circus is ending in a few months. It's coming to Atlanta for the last time next month, so that's very sad. And there's no elephants anymore at Barnum and Bailey. So let's do some math then. Now, even if when you're in my classroom and you're looking at my two-way frequency table that I keep up on the board, even if you can understand it and you know what you're looking at, chances are this vocabulary is going to be new to you. So let's go ahead and get that part out of the way because let's be honest, that's the least fun part. When you're looking at a two-way frequency table, the joint frequencies, I should have made that plural, the joint frequencies are the numbers in the middle of the table. So there are these pieces of data that join two values. So this 3 here is boys who like clowns. This 4 is girls who like acrobats. So it's putting two different pieces of information together. That's why we call them joint frequency, because they're joining two categories. So the example we give is how many girls liked acrobats. Oh, I already talked about that. It's 4. The other piece of vocabulary is the marginal frequencies. Marginal frequencies are your subtotals. So we're not talking about this overall total of 20 kids. We're talking about these totals that give you the total number of people who like clowns, or the total number of people who like acrobats, or elephants, or the total number of boys or girls. They're found along the edges of the two-way frequency table or along the outside. Kind of think about the margins of your paper in English class. You talk about how wide your margins have to be in a research paper. So it's along the edges. Right, we got a little bit more vocabulary and some formulas to go along with it. Similar to the joint frequency is the joint relative frequency. In order to calculate the joint relative frequency, what we're going to do is divide a joint frequency, so one of these internal values here, by the total number of values. So here's your equation. So I'm going to look at example 1a to show you what I mean by that. This is for joint relative frequency. Okay, we want to know the joint relative frequency of boys who like the elephant tamer. So I'm going to go to my boy row and pull the elephant tamer number, which is 8. That's going to be my relative frequency. And I'm going to put that over the total number of data values. So my total number of data is 20. Then I'm going to actually divide that. So 8 divided by 20, make sure you're putting 8 in first, and I get 0.4. Sometimes you'll see it written as a decimal like this. Often you will see this written as a percentage. So 40% of the people surveyed were boys who liked elephant tamers. All right, The second example here, the second thing we're going to talk about is marginal relative frequencies. Marginal relative frequencies can be found in a similar way, but now we're looking at an entire category, not just one of those joint frequencies. So we're going to pull a marginal frequency, one of these values that's a subtotal, and compare it to the total data values. So a problem would look like this: a marginal relative frequency of students who like clowns best. So what that means is I'm going to go to my total number of kids who liked clowns. That's going to go in the numerator of my formula, and then I'm still going to use the total number of data. So I'm looking at the total number of students who liked clowns, and that's going to be 5 out of 20. Then again, I'm dividing 5 over 20, and I get 0.25 or 25 hundredths. Again, sometimes you'll see it written this way, sometimes you'll see it written as a percentage. You've got to be prepared to see either one and know that they are equivalent to the same thing. All right, so that's it with the vocabulary part. Now I'm going to show you what you're most likely to see, and this is conditional frequencies or conditional relative frequencies. So this is one last, I lied when I said I was done with the vocabulary. Here's one last little bit of vocabulary. Conditional relative frequency is a ratio of a joint frequency and a marginal frequency. So this would be if I wanted to know the number of girls whose favorite performer was the clown. So let me go back over here. So I'm looking at the number of girls, so I'm looking here, whose favorite performer was a clown. So I'm going to take 7 and clown, and that's what I'm going to write as my ratio. So I want, there were 7 total girls, so that marginal frequency was 7. 2 of those girls liked clowns, so the joint frequency was 2. So let's flip back real quick. I'm putting a joint frequency over a marginal, looking at girls who like clowns. So my joint frequency there is 2, the marginal is 7. Okay, so again, I'm going to actually divide that. Don't leave it as a fraction. You rarely see them as fractions. And it's going to be a crazy decimal here. If you can see it, you get 0.2857. Just round it to 29. That's fine. So it would be 0.29. You might want to do squiggles to say it's approximately 0.29, which would be 29%. Okay? Now, rarely will you actually see somebody ask for conditional relative frequency or marginal relative frequency. Instead, you're going to have problems like this. So this is the more beneficial example to you because this is what you're going to see probably on mastery checks and tests and things. And this is what you're going to need if you ever have a two-way frequency table that you're working with in real life, then you're probably going to be looking at examples like this. So we've given you a two-way frequency table where we're looking at basketball concession stands. We've got hot dog, pizza, or they didn't buy any food, and then over here we've got soda, water, and no drinks. So I don't know what these people bought. Maybe they didn't buy food or drinks. Maybe they just bought a ticket, or maybe they bought one of those programs or something. So what percentage of people bought no food and no drink at the concession stand? So when you're trying to write this, you are going to have the part over the whole. Okay, so the portion of people you're looking for is going to go on top. The entire group of people you're asking a question about is going to go on the bottom. So I want people who bought no food and no drink. That's going to be 10 because no food, no drink. Compared to what percent of people. Oftentimes this whole is going to come from wherever you see that word of. That's going to tell you what you're looking for. So what percent of people? Well, the total number of people was 400. It wants a percentage, so I'm going to have to divide that 10 divided by 400, and I get 0.025, which as a percentage, I move this over 2 spots and I get 2.5%. So 2.5% of people didn't get any food or drinks. Our next question asks a slightly different kind of question. It says, what percent of people who bought pizza? So my of statement tells me, remember, it tells me my whole. I'm going to have part over whole. My whole is all the people who bought pizza. I want what percent of people who bought pizza also bought soda. So of people who bought pizza means I'm looking for the total number of people who bought pizza. That's going to be my whole. My part is the portion of these people who also got soda. That's my 120. So I'm going to have 120 over 182. So I definitely can't do that division in my head. 120 divided by 182, and I get a crazy decimal. Hopefully you can see that. I'm going to round that to 0.66. Yep, 0.66. Which as a percentage, I move my decimal, and I get approximately 66%. Right? Let's do another one. Let's do this one in blue. What percent of people bought hot dogs? This time it says of people. So that means my whole is back to the entire 400 because I didn't qualify it with just pizza buyers or just soda drinkers or whatever. So what percent of people? So I'm putting 400 as my whole. My part are all the people who bought hot dogs. So my part is that 158. Okay, so I'm going to divide 158 divided by 400, and I get 0.395. If it's a nice, simple, short decimal like that, I probably wouldn't round. I would just say 39.5%. So this equals 0.395, which is equal to 39.5%. All right, the last kind of question we could ask is for you to interpret this or draw some conclusions from what you see. So it says, what conclusions might you be able to draw from this two-way frequency table about concession stands? So this is an open-ended question. There's all sorts of things you could say about it. You could say that most people who go to concession stands do buy food because, you know, we only had 2.5% that didn't buy any food, that just bought souvenirs or whatnot. We can see that a lot of people bought soda compared to no drink. Well, I guess half the people bought soda. The other half either got water or nothing. So that was very popular. We also had quite a lot of people buying pizza. So maybe you can draw a conclusion that people don't tend to eat very healthy when they go to the concession stand. It's really, it's just an opinion. As long as whatever your opinion is, you back it up with some math. So you say, the reason I think that people tend to drink soda at concession stands is because 50% of the people who visited this concession stand got a soda. The reason that I think that people aren't very healthy is I can see how many people bought pizza and soda right here at this 120, and 120 over 400, that's a pretty high percent of people who are getting a high calorie meal there. So, you know, there's lots of things you can pull from that, but the trick to these, it seems like the vocabulary is the tricky part, but that doesn't tend to show up very often. The trick is knowing what we're asking, paying attention to this of statement so that you know what that bottom portion of your fraction is going to be, because that's where people tend to get mistakes. So there is not an application for this lesson. You do have quite a lot of practice, and I do recommend that you do close to all of it, because really we can ask questions in a lot of different ways, and it's easy to get tripped up and you think that you completely understand it, and really there's little nuances that you can only fix through practice. So complete the practice, make sure you check your answers so you know you're doing it right, and then come get a mastery check from us, and then good luck on your last lesson. Bye.